Let's apply all that we have learned to one last problem that we can see it on this part of triangle. So what is being said? Triangle ABC is right angled at B. Okay, AC is 12, angle ACB is 30. O is the in center. Okay, I'll have to draw an in circle for that. Then the distance OB. So let's draw everything. I need to draw a right angle triangle ABC. So first I draw that. It is angled right at B. So B is 90. That's how I draw this. Then what? AC is 12. Okay, so the hypotenuse AC is 12. I'll write it there. Then given angle ACB is 30, so I'll make ACB as 30. That is also clear. In center, O is an in center, so first I'll draw an in circle for that. O will be the in center. I will have an in radius. Obviously, if I have an in circle, I'll draw an in radius for that. So I'll put an in radius in this way. If you know by tangent perpendicularity, this will become 90. Okay, as we have learned, a line from the center to the tangent is always perpendicular. So I know this is 90. I need to find out OB. Yes, this red is something that I'm supposed to find out. Find the distance OB. Okay, and that is my concern right now. So how will I start? What is given to me? One angle is 90, other is 30. The next has to be 60. So I can apply 30, 60, 90. Hypotenuse is given. Side opposite to 30 is half, so it becomes 6. Side opposite to 60 multiplied by root 3. So this becomes 6 root 3. So I know what is BC right now. Now what do I need? I need OB. Okay, OB I can get if I can get in radius. Okay, if I can get an in radius, I can apply 45, 45, 90 because I know there is a square that is being forming there. So all I need to do is get an in radius. Where can I get an in radius? In the formula of area. We have learned area is equals to R into S. Okay, so I need to get it by this. But one more formula for area is half into base into height. So base is 6 root 3 into height is nothing but 6. So this comes out to be 36 root 3 divided by 2 is nothing but 18 root 3. Okay, that is now the area of this triangle. Area of triangle ABC is 18 root 3. But the same area of triangle ABC could be written by one more formula. We had seen 5 formula. For in radius is R into S. So 18 root 3 is equals to R into S. But S we know is nothing but semi-perimeter. So perimeter you will write all the sides 12 plus 6 root 3. Semi-perimeter divided by 2. 18 plus 6 root 3 divided by 2 is nothing but 9 plus 3 root 3. So I have this 18 root 3 is equals to R into 9 plus 3 root 3. Okay, so my in radius R comes out to be what then? 18 root 3 upon 9 plus 3 root 3. Okay, take out 3 out of this. So what can I do right now? 18 3, I'll take out 3 out of this. So what am I left with? 6 root 3 upon 3 plus root 3. Again I think I can simplify this because there is a root 3 and 3 there. So what will I do? I'll take out root 3 common from the denominator. Okay, what am I left with? Root 3 plus 1. Now root 3 gets cancelled. What am I left with? 6 upon 1 plus root 3. That's it. That is my in radius for this triangle ABC. Now by tangent perpendicularity, I told you at the start this too will be 90. We had done such sum earlier. So this will also be 90 because the 3 angles are 90. The two sides, angle between them is 90 and they are equal. It will form a square. Square as an angle bisector. So the angle will be 45. It forms in 45, 45, 90. For which I know the two sides, which is R. So hypotenuse will be equal to what? R root 2. Okay, we have done one of such sum earlier. So hypotenuse will be equal to R root 2. Okay, just multiply this by this. That's it. So I have OB is equals to R root 2 and OB is equals to 6 upon 1 plus root 3 into 2, and that is my OB now. Okay, so I hope you got good concepts with respect to learning of triangles. Okay, I'll see you in the next class for quadrilateral and polygons.